today's question is really about, error handling. That's how the person here asked for it. But it's really about temporality, about links. So the question is this. We have a link table modeling a relationship between two hubs. So, okay, it's easy. Two hubs, left, right, and it's in the middle, essentially. And then the rule is, so there's a business rule involved, apparently, that a hub A can only be related to one other entity of hub B at any given time. You can't have a relationship between A, B, and between two different records or business keys in B, essentially, related to A. That's the idea. So it's a one-to-one relationship that they want to enforce or want to essentially establish. So first, what happens is the source system links, or the source system sends a run record that creates a relationship in a link between a business key from A1 to B1. Easy. Okay, so that's being loaded in the link table. That's fine. Then the source makes an error, or makes a change, doesn't matter why it's changing the data, and creates a new relationship between A1 and B2, between the second to the second business key of the hub B, essentially. And then they load this new relationship. So all good. What we see now is that you get two link entries, and between two different business key sets, and then there's a different load involved, right? Because you had the first load on the first day, the first relationship, and the second relationship came in with the second load, essentially. So it has the higher load date. That's what we see when we're looking at the data, essentially, inside the link. But then the source system corrects the error, linking A1 back to B1. And then the question comes, how to correct this relationship, essentially. Where it comes again, how do we load it so it's clear this is the newest, most current record? Because they realized most probably that when they load the same previous relationship between A1 and B1 again to the link doesn't care, right? Because it knows this relationship already, and the link is a distinct list of all the relationships ever loaded into a data warehouse, right? So because the link knows this relationship between A1 and B1 from the past, it will not load a new record. It will not update load date. There's no update on load date, right? So how do you recognize what the latest row is? It's not based on the load date. The load date only indicates when did you source or when did you see the relationship for the very first time? When did you load this? That's it. But it doesn't tell us in any way, shape, or form what's the latest record business-wise, right? Now, what's missing here? Please don't. Let's start with the other patterns here. Please don't introduce some load end date to the link to indicate that the second relationship is outdated somehow. The load end date is not used for defining or for setting a soft delete or something, right? So where you indicate that the record has been outdated, removed, deleted from the source, like the second relationship is not there anymore, so it's end date is no. There should be no end date, load end date no end date at all. In the link relationship, okay? So that's number one. So it's done by a satellite. There should be an effectivity satellite involved that keeps track of from when to when a relationship was active source-wise. And typically what you have is some fact from the source system. For example, and by that I mean you have the physical existence or non-existence of the record, right? That's also a fact. It's maybe not an attribute, but it's also a fact about the record. Does it exist or does it not exist? So in the most simple case, let's say we have full loads. You could compare what you have in your link, what should be active according to the effectivity satellite, and compare it to the staging area to see what's still there. Because in the full load, every active relationship should be there. Every active relationship that we know should be there. And if it's not there anymore, it must have been deleted. That's the assumption, which holds true actually for many source systems. So the basic idea is this. We have two entities now. We have a link entity and a satellite, effective satellite. So in the link and in the satellite, in the link table, we get for the, let's say, LDTS, for the BK, A, BK, and there's also the hubs related, right? So that's true. So I'm just adding the business keys here. I'm not hashing them, right? So on day one, we get the relationship A1 to B1. That was the basic idea. So that's what we get to B1. And what we also add to the satellite is essentially a deleted date. That's what we maintain. So for the records, let's do this. H key, load date timestamp, and deletion date time stamp. So for the record, A1, B1. That's sorry for that, but that's the hash key for the first relationship essentially. On day one, we know the record exists because the source system delivered us the relationship. So we set this deletion date timestamp to the end of all times. 8. I wouldn't use 999 December 31 because sometimes you have to do some arithmetic on these dates and then you have an overflow. So that's why we always use 888, the December 31 of 8,888. It's also a lucky number in China, maybe works. So that's number one. So that's the first record. That's the first day what we get. On day two, there's a new relationship introduced. So we add a new hub entry for B2, right? And then we add the relationship. It comes in on day two from A1 to B2. That's the second row in the link. And we know we have two more data artifacts. So we know, for example, that on day one and day two, the old relationship doesn't exist in the source anymore. So for A1, B1, on day two, I can set this to the current load date. That's when I recognize this record has been deleted. So I'm setting this to D2. That's when I recognize the record has been, the relationship has been removed from the source, or it's not being delivered, however you want to define it. And then I also know about the new relationship. It has been introduced. It's active. So I'm adding A1, B2 on day two with open-ended. Open-ended here means it's active, right? It's not deleted. And then on day three, when the old relationship comes back in again, there's no impact on the link because the link doesn't care. It knows this relationship already between A1 and B1. That's where you're reverting to, right? So it knows this relationship already. But we have more facts. We know, for example, that the second relationship between A1 and B2, that's outdated. So it's deleted. So we get rid of that. A1, B2 on day 3 is ending on day 3. That's when we recognize the deletion. And then on I see some comments here in chat. A1, B1, day 3, I'm activating this again with an active open end date, with an active deleted date essentially. So that's the basic idea. That's how we keep track of all these changes. And if the relationships, let's say they realize, well, that's all nonsense. The second relationship is actually the active one. Let's reactivate this to just go on satellite. You just get rid of or turn off or soft delete the relationship, the current relationship between B1 and A1. Soft delete it again by setting the load dates, the deleted date to the active load date. And then you reintroduce the delta for A1, B2 and activate it again. That's the basic idea. By setting the deleted date timestamp to the end of all times. So I saw a couple of, so that's the solution essentially. But I saw some comments here. Let me just go for a chat. So from Peggy, why not use a status C create or D delete, for example? You can do that. So especially, it depends a bit on your loading pattern. So first of all, do we need to use a deleted date timestamp or should we use some flag? Is active, is deleted, for example, right? You could do that as well. It's just that the deleted date timestamp gives me a little bit more information. I not only know the record has been deleted or it's currently active, I also know when I recognize the deletion. So I can query it easily. But I fully agree with you. It's typically, but not always, typically in line with the load date of the record. Now, again, it just says, when did I recognize this record being deleted? I don't know, to be honest, that this record has been deleted at the same time of my load. I would not assume that, to be honest. But that's all I have. I just know from this load, and loads are identified in Data Vault using the load date timestamp. On this load, I recognize this record being removed from the batch. And then it depends a bit on how you get data being delivered. So if you assume full loads, you just compare all the link entries with all the active link entries. So you essentially join the Effectivity satellite to the link table, and it gives you the active link entries quickly because you essentially just query all the links, join the Effectivity satellites, and then filter down to the rows where the deletion date timestamp for the most recent deltas, right? Type 1, sorry, for the most recent deltas is currently active. It's not deleted. Those records must still exist in the staging area in your full load. If not, Then we insert a delta into the satellite, where we set the deletion date timestamp, or your is active flag, for example, or is deleted flag, to the current load date timestamp when we recognize the deletion. Okay, so that's the basic idea of this. And then it depends a bit on loading. So if you get CDC data, you would use the you have a bit more information actually, because you have a CDC timestamp where you essentially get the information when the record was when you received a notification from the CDC pipeline that the record got deleted in the source system. That's even closer than your load date. So I would prefer that CDC timestamp of your deletion as the deletion timestamp, and then the load date timestamp of your satellite. I'm sorry, I have it only on the screen here anyway. Then the load date timestamp of the satellite and the deletion timestamp is not in line anymore, because you received the CDC record at certain timestamp. There's ways how we capture CDC data in satellites. They all apply essentially with adding microseconds to the load date. And then you have the CDC timestamp, and that's the current. That's the most current or most best value they can get essentially, at least in CDC. So that's the basic idea. And then if you get deltas and so on, there's different options how you load this deletion timestamp in the Effectivity satellite in the scenario section. It really depends on how you get the data essentially. CDC, full loads, real time, and so on. Incomplete deltas where you only get inserts and updates, but no deletes. That's an issue. Longer story? Well, not long story actually. So let's say you get deltas with only inserted and updated rows. But the delta, in my opinion at least, is including the inserts, the updates, and deletes, because otherwise you don't know what got deleted. Just because it's not getting updated or inserted doesn't mean it's still there, right? So that's the incomplete delta. How do we solve this? And first of all, I would try to get, in theory, my preferred choice for master data is a full load, and for incremental data, like transactions, events, it's an increment, right? But including deletes and so on. It's the best case scenario. And I actually prefer CDC data because then I have a full delta anyway, right? So that's what I actually prefer, CDC over everything. And then I would like to go for full loads for master data and incremental loads for non-historized data, events, messages, and so on. I wouldn't get that, right? Because if I go to the source and say, well, can I get the full load of all your customer records, 80 million customers, with hundreds of attributes, they would say, no, it's too large. And I get that. It's really too large. So that's why you get only the delta with only the inserted and updated rows. Why don't you get the delete? Because they deleted the row in the first place in the source system, so they don't have it anymore. So they can only give you the inserts and updates. Don't even try to get the deletes. They don't have it, period. Now, how do we solve this? How do we figure out which records have been deleted in the source with this incomplete delta? And the trick is, while you can't go back to the source and ask them for a full load of all the records and of all the attributes, I'm going back to the source system and asking them for a full load, but only of the business key that I chose for the hub that's involved here. Only for the business key, because that's the only thing which is required to identify the deletion. If the business key, or in this case the relationship actually, if the relationship which is active according to the Effectivity satellite is not anymore in my full load of the relationships A1 to B1 and so on, in my staging area, only 2 columns here, then it must have been deleted. So I don't care for all the descriptive attributes. So give me a delta, an incomplete delta for your records, for your relationships here. Incomplete means, again, only the inserts and the updates, and give me a full load of the business keys involved in this relationship. And nobody can tell me that that's a large data set. That's small stuff. It's only 2 columns, maybe 3, and so on. On hubs, it's only a few columns. Yes, lots of records, but only a few columns. That's not a big data set. Sorry. Even 80 million, 100 million rows, that's a small data set. Period. Seriously. The problem is, while technically that's a small data set, you now are in the political games here. They don't have the consultants, no resources, no knowledge, no whatever. So they don't want to produce you that, but it's all political reasons. Good luck on that. You can essentially deal with all these reasonings, but you have to deal with them, right? So it's political game. But technically, there's no reason why they can't offload this data if it's only 2 or 3 columns. No way that anybody can tell me this. So that's enough for identifying the deleted records, and then we can insert, based on this knowledge, we can then insert 1 delta into the Effectivity satellite for every missing record and set the deletion date timestamp or active flag to end of all times or active is false, essentially. That's the basic idea. And if the record comes back again later, well, then you have a new record in the staging area where in the target, and by target I mean in the link joined with the effectivity satellite, the active rows where the delta's deletion date timestamp says it's deleted, which means that the deletion timestamp is set to a date timestamp other than end of all times. It's not end of all times, to make it easier. So if that's the case, if you're looking at a relationship in your staging area where the effectivity satellite says, I don't know this one, or it should be deleted, then you insert not only the relationship into the link if it's not there already, and you insert the delta into the satellite and set the deletion date timestamp to end of all times again. That reactivates the relationship and you're done. That's the basic idea. How about using last seen date in the link? So the last seen date has a different purpose. First of all, to some extent you're right. So first of all, the assumption here that I made is that you have a reliable source system. That's you can rely on the fact if the relationship is not there anymore in your full load of your business key combinations in the staging area, then you assume here that the relationship has been removed from the source and we have to soft delete the record essentially. That assumption doesn't hold true all the time. Because what if you have an unreliable source system where they send you most of the relationships, most of the business keys essentially, but sometimes they lose some business keys for whatever reason. Maybe they don't export the data into the file. Maybe the file gets lost or the business key gets lost somewhere during transmission of the file from the source system all the way to your staging area process. Or you don't load the record for whatever reason into your staging area. So it gets lost on the way essentially. In some reasons is when you have in some cases when you have a lock on the record in some mainframes, you have a lock on the record because people are editing the record, and then when they hit home essentially in the night, they keep the UI screen open and it keeps the lock active. And when the export job starts in the night, they exporting the data except the locked rows. So once in a while you have a few records which are currently in edit mode, which exist in the source system, but they are locked, and that's why you don't get them. And then days after they appear again and so on, right? So in this case, we consider the source system delivery as unreliable, and we have to do something here. And the idea now is to use the last seen date for this purpose to indicate when we have seen the business key or the relationship for the last time. And then, because that's a fact, right? Did you see the record or not? And then we can use that information or this data in a later business rule in the business vault to apply some rule like, if you have not seen the business key or the relationship for a while, let's say 3 weeks, if you haven't seen this for 3 weeks, then consider this business key or relationship as being deleted. And then we set a delta into the effectivity satellite and indicate this record as being deleted, essentially. The problem is nobody knows. It's the best guess, but it's not an educated guess, but it's the best guess you can make, essentially. And that's the idea. So I mean, nobody knows. You can't look into the source system, and you have to work with delivery essentially. And then that's the best guess you can make essentially. And because we don't know, it's not a fact. It's a business rule. Somebody tells us when to consider a business key as being deleted, and that's why we essentially want to do this in the business vault, and also in a way where it can switch back and forth. We teach this extensively in the DV8 training, so that there's a section on last seen dates and how we do it. How do we do it essentially? Okay, cool. Good question. Thank you for joining us today. Remember to subscribe to our channel and activate notifications. To build a scalable design data platform, read a free Data Vault Handbook by scanning the QR code or following the link. Bye, guys.